Hi there, this is brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Today's lesson is taken from Brilliant Maths Module 8, and we're going to learn mappings, relations, and functions. Get a copy of the book and let's go to class. In this lesson, we want to look at relations, mappings, and functions. A relation is a connection between two sets. It associates the elements of one set to the elements of another set. So for example, we have Kemi, Dan, Ama, Tom, and Ngozi. They are all friends in a particular set, let's say set X. And we have the countries from which they come from: Ghana, Nigeria, Togo, and France. The set X is the domain of the relation, and the set Y is the codomain of the relation. So from the diagram we have on the board, Kemi is from Nigeria, Dan is from France, Ama is from Ghana, Tom is from France, and Ngozi is from Nigeria. From the domain, there's nobody in the codomain from Togo. So the image of this domain would be the countries that actually have people from them. That's Ghana, Nigeria, and France, with the exception of Togo. So the image of this domain will be Ghana, Nigeria, and France. There are different types of relations. We have one-to-one relation, where every element in the domain has an image in the codomain. When you have that, that is called a one-to-one relation. For example, we have the set X with 1, 2, 3, and the codomain 3, 6, 9. The relation is times 3. So 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. So in this type of relation, each member of the domain has a unique image in the codomain. Next, we have one-to-many relation. Here, the domain is 3 and 4, and the codomain is 9, 18, 8, and 6. And the relation between the two sets is a factor of. So 3 is a factor of 9. So 3 has an image in the codomain. 3 is also a factor of 18. So that's why it's called one-to-many. One member, one element in the domain to many in the codomain. One element has more than one image. So 3 has 2 images. 4 is a factor of 8, and 4 is a factor of 16. One-to-many. So the next type of relation is the many-to-one relation. And here, our relation is a multiple of. So we have 12, 15, and 36. It's a multiple of. So 12 is a multiple of 12. 15 is a multiple of 5. 36 is a multiple of 12 and a multiple of 9. So many-to-one, signifying that 12 and 36, that is more than one member of the domain, has one image in the codomain. So many-to-one. 12 and 36 have one image. So that's an example of a many-to-one relation. And then the fourth type is many-to-many relation. And this relationship here is greater than. So we have 6 and 7 in the domain, and we have 2, 3, and 5 in the codomain. 6 is greater than 2, 6 is greater than 3, and 6 is greater than 5. So 6 one element or one member of the domain has 3 images in the codomain. 7 is greater than 2, 7 is greater than 3, and 7 is greater than 5. So we have many-to-many relation. This is very interesting. Just take your time to understand what the relationship is so that you can identify the members of the codomain. We are looking at relations, mappings, and functions. We have already defined relations. A mapping is a relation in which each member in the domain maps onto only one member in the codomain. The first set is the domain, and the second set is the codomain. So what that means is that each member, each element in the domain has only one image in the codomain. So when you have that, then it is a mapping. So that implies that a one-to-one relation and a many-to-one relation are mappings. We should note that a one-to-many and a many-to-many relation are not mappings. We defined all of this in the first segment. So examples of mappings, this is a one-to-one mapping. 1 maps to 4, 2 maps to 8, and 3 maps to 12. The relation is times 4. That's the rule of the mapping. So 1 times 4 is 4, 2 times 4 is 8, and 3 times 4 is 12. Another mapping here is months of the year and the number of days. So January, June, and July. The relation is has. January has 31 days. June has 30 days. And July has 31 days. So this is a many-to-one mapping. More than one member of the domain map to one member of the codomain. So these are 2 examples of mappings. Next, we want to learn how to find the rule of a mapping. Example, what is the rule of this mapping? X maps to Y. 1 maps to 1, 2 maps to 3, 3 maps to 5, 4 maps to 7, and 5 maps to 9. Study the mapping. What do we notice? The domain is 1, 2, 3, 4, 5, and the codomain is 1, 3, 5, 7, 9. So what is the rule? What happens to the number in the domain to produce the number in the codomain? By inspection, we can see that each number is mapped to twice itself minus 1. So 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, 4 minus 1 is 3. 2 times 3 is 6, 6 minus 1 is 5. So obviously, that is the rule for this mapping. For any element x, the rule of the mapping is 2x minus 1. X maps to 2x minus 1. So to check, we've already done that. When x is 1, 2 times 1 is 2, 2 minus 1 is 1. And when x is 4, 2 times 4 is 8, and 8 minus 1 is 7. So the rule for this mapping is 2x minus 1. For more examples, get a copy of Brilliant Maths, Module 8. We are still looking at relations, mappings, and functions. A function is a mapping in which each element in the domain has one and only one image in the range. Note that only one-to-one and many-to-one relations are functions. That means that one-to-many and many-to-many relations are not functions. An expression in the form 3x minus 2, in which the variable is x, is called a function of x. So that function is in terms of x. The numerical value of the expression depends on the value of x. So this is written as f of x is equal to 3x minus 2, or f x maps to 3x minus 2. So for example, if f of x is equal to 4x minus 2, find the value of f2 and f minus 3. What does that mean? It means find the value of the function when x is equal to 2, and find the value of the function when x is equal to minus 3. So let's quickly do that. So the solution, the function is f of x is equal to 4x minus 2. So when x is equal to 2, we simply replace x with 2. So 4x becomes 4 times 2. So f2 is 4 times 2 minus 2. So that is 8 minus 2, which is equal to 6. So that the numerical value of the function when x is equal to 2 is equal to 6. So next, to find the numerical value of the function when x is equal to minus 3, f minus 3. We simply replace the value of x with minus 3. So it's 4 times minus 3 minus 2. And 4 times minus 3 is minus 12. Minus 12 minus 2 is equal to minus 14. So let's look at other examples. So let's look at this example. If f of x is equal to 6x plus 16 and f of x is equal to 10, solve for x. That is very easy. What have we been given? We have that f of x is equal to 6x plus 16. And also, f of x is equal to 10. That implies that 6x plus 16 is equal to 10. So 6x plus 16 is equal to 10. We have a linear equation in x. So we simply solve that equation. 6x is equal to 10 minus 16. And 10 minus 16 is minus 6. So 6x is equal to minus 6. So x is equal to minus 6 over 6, which is equal to minus 1. See how easy it is. You can get more practice from Brilliant Maths Module 8. So here we want to look at inverse functions. What is the inverse of a function? The inverse of a function is its reverse. It's as simple as that. The reverse of a function is the inverse. So the inverse of a function f of s is written as f to the power minus 1 x. It's just called f inverse of x. Example, find the inverse of the following functions. The first function is f of x is equal to 2x minus 3. And the second function is f of x is equal to 3x minus 1 over 2. The steps to finding the inverse of a function are as follows. First, make x the subject. Then after you have made x the subject, then you change your x to f prime of x or f inverse of x, and then change your f of x to x, since the reverse is the inverse. It's very simple. So f of x is equal to 2x minus 3. So solution, f of x is 2x minus 3. You write out the function again. Make x the subject. So the target is to make x the subject. So 2x is equal to, we take minus 3 to the other side of the equation. So 2x is equal to f of x plus 3. So x is equal to f of x plus 3 over 2. So since the reverse is the inverse, we now change our x to the inverse, f prime of x, and then change the f of x to x. So f prime of x is equal to x plus 3 over 2. So the inverse of 2x minus 3 is x plus 3 over 2. In the second example, f of x is equal to 3x minus 2. So solution, make x the subject. So we have 2f of x is equal to 3x minus 1. So 3x is equal to 2f of x plus 1, because the minus 1 crosses over to the other side of the equation. So that our x is equal to 2f of x plus 1 over 3. So the final step is to swap your x, which is now our inverse, is equal to, swap the f of x and make it x. 2x plus 1 over 3. You can try many more exercises and examples from Brilliant Maths Module 8. Still looking at inverse functions. If g of x is equal to 3x minus 2 over 5, evaluate g inverse of 5. So find the numerical value of the inverse when x is equal to 5. So the first task is to find the inverse of the function. Now remember the steps. First, make x the subject of the function, and then swap your x, change your x to the inverse, and change the function to x. So first step, make x the subject. So we'll cross multiply, we have 5 g of x is equal to 3x minus 2. We want to make x the subject, so 3x is equal to 5g of x plus 2. So that x is equal to 5g of x plus 2 over 3. So that's the inverse now. So we swap g inverse of x is equal to 5x plus 2 over 3. We are done with that. So the next task is to find g inverse of 5. So next we are going to find the value of the inverse when x is equal to 5. So g inverse of 5 will be equal to 5 times 5, because the value of x is now 5. 5 times 5 plus 2 over 3. So g inverse of 5, 5 times 5 is 25. 25 plus 2 is 27. 27 over 3, which is equal to 9. So g inverse of 5 is equal to 9. This is actually very easy. Take your time to solve some more problems. So here we're looking at composite functions. Composite functions deal with more than one function. It is also called function of a function. So for example, given that f of x is equal to 3x and g of x is equal to x minus 1, find g f of x and find f g of x. How does this work? It simply means g f of x becomes g, replace that with what you have as f of x, 3x. And then next, g3x, that means that the value of x now is 3x. So in the function g of x, anywhere you find x, replace it with 3x, and that will be the answer. So g3x will be equal to x minus 1 becomes 3x minus 1. So g f of x is equal to 3x minus 1. So let's now see f g of x. f g of x. So in the same manner, we replace g of x with x minus 1 so that f can now act on it, x minus 1. And in our function f of x, wherever we see x, we replace it with x minus 1. So f of x minus 1 is 3x, and that becomes 3 into x minus 1. If you simplify that, so we have that f g of x is equal to 3x minus 3. We can see that gf of x is different from fg of x. So just take your time and work more examples. Let's look at another example. Let's look at one more example working with composite functions. Remember that composite functions deal with more than one function. Evaluate gh of minus 3 if g of x is equal to 6 into minus x plus 2 and h of x is equal to 3 plus 2x over 5. Please pay attention. This is a little complicated. So g of x is equal to 6 into minus x plus 2. And h of x is 3 plus 2x over 5. So we want to find gh of minus 3. So first we'll find gh of x. So gh of x, what is our h of x? We replace this h of x with 3 plus 2x over 5. So we have g into 3 plus 2x over 5. So in the function g now, wherever we find x, we'll replace it with 3 plus 2x over 5. So that's equal to 6 into minus 3 plus 2x over 5, then plus 2. Because this is now our x, plus 2. So next, I'd like to open up the first bracket. So 6 times 3, that will be minus 18 minus 12x all over 5 plus 6 times 2 plus 12. So next, I can simply make both of them a denominator of 5 so that becomes minus 18 minus 12x plus 60 over 5 by simply multiplying 5 by 12 to give me 60. If I divide the 60 here by 5 to take it out of the denominator, it will give me 12. So collect like terms now. That will be 60 minus 18 minus 12x all over 5. So my final answer, 60 minus 18 will be 42. 42 minus 12x over 5. This is equal to gh of x. But the value of x should be minus 3. So substitute minus 3 into this expression. So minus 3 times minus 12 will be positive 36. So that we have 42 plus 36 over 5. And what does that become? 78. 78 over 5. And 78 over 5 is equal to what? 5 into 7 will be 1, remainder 2. Into 28 will be 5. 25, remainder 3. 3/5, which is the same as 15 3/5 or 15.6. So that is the value of GH of minus 3. And that's the final answer. For more exercises and more examples, get a copy of Brilliant Maths Module 8. From here, we have minus 18 minus 12x over 5. But I'd like to put all of them under one denominator so that the LCM is 5. So what do I do? If I'm putting all of that over 5, then I'll multiply the 12 by 5 to give me 60. So plus 60. So now I have minus 18 minus 12x plus 60 over 5. Collect like terms now. So I have 60 minus 18 minus 12x over 5. 60 minus 18 is 42. So I have 42 minus 12x over 5. So this is equal to 42 minus 12x over 5. So this is my GH of x. So that is GH of x. What were we supposed to find? It says evaluate GH of minus 3. So meaning when x is minus 3. So next, we're going to substitute the value of x. So x is supposed to be minus 3. So what do we have? We have that's equal to, so we have GH of minus 3 is equal to 42 minus 12 times 3 over 5. 12 times minus 3, please. So 42 minus 12 times minus 3 over 5. So we have 42 minus 12 times minus 3 will give us plus 36. So 42 plus 36 over 5. So our GH of minus 3 will be GH minus 3 is equal to 42 plus 36 will be 78. 78 over 5. And 78 over 5, if we want to convert that to a mixed number, 5 into 7 is 1, remainder 2. 5 into 28 is 5. 28 minus 25 is 3. So that's 15 3 over 5, or 15 3/5 is the same as 0.6, or 15.6. We have answered the question in full because we were told to evaluate GH of minus 3 if G of x is equal to 6 into minus x plus 2 and h of x is equal to 3 plus 2x over 5. So we evaluated GH of x and we found GH of x to be equal to 42 minus 12x over 5. Having found that, we then input the value of x, which is minus 3, into our composite function. So when we put that value, the value of x, which is minus 3, we get GH of minus 3 to be equal to 78 over 5, or 15 3/5 as a mixed fraction, or 15.6 as a decimal number. For more examples and more exercises, get a copy of Brilliant Maths Module 8. Hello, I hope you enjoyed the lessons on relations, mappings, and functions, how to identify the rule of a function, and when is a mapping a function and when is it not a function. We also learned how to find the inverse of a function, and we learned composite functions, finding the function of a function. All of these were taken from Brilliant Maths Module 8. Subscribe to brilliantmaths.com. Follow us on all our social media handles, and you will be on your way to success in maths. My name is Ngozi Orevogene, and always remember that maths is fun and you can excel in it.